Our next video will be about law of cosines application questions. Now, as we went through the law of cosines lesson, a lot of you were asking some questions about the problems where you have to find the missing angle. The good news is we're going to do more practice with that because every question that's in this lesson begins with finding one of the missing angles in a triangle where I know all of the sides. Our questions are going to start with the easiest example and progress to the hardest example. Example 1. Find the vertex of an isosceles triangle with legs of 8 centimeters and a base of 10 centimeters. Now for this problem I went ahead and showed a picture. For every example I give you, there will not be a picture provided on the test. You need to provide the picture. So I'm going to always do that with each example. For example 1, we want to find the vertex angle of an isosceles triangle with legs of 8 centimeters and a base of 10 centimeters. Since it's been a while since we've seen isosceles triangle questions, to be exact about chapter 4, I want to make sure we remember the vocabulary. The vertex angle is the angle that does not have a congruent match. Remember, in an isosceles triangle, the two legs that are the same have matching angles that are the same. We're trying to find the vertex angle, which is the angle on the top. Just like I said, we're going to need to use the law of cosines to be able to find it. Our first step is to plug in our numbers into the formula. So the side opposite the vertex angle squared equals the other two sides squared added together minus 2 times the product of the two opposite sides times cosine A. Many of you were saying you're starting to get very used to the formula, and that's good. You should be kind of beginning to be more comfortable about where you plug in your numbers. I went ahead and simplified all of the squares, and I even added together 8 squared and 8 squared, and I simplified 2 times 8 times 8. Whenever you have an isosceles triangle and you're finding the vertex angle, you will notice this happens. These two numbers will be identical. Just like we said before, we cannot combine these two and just say 0 times cosine A. Cosine A is just like having a variable like x. I can't put together things that are not like terms. So what I need to do is I need to isolate my cosine of A by getting rid of this first 128. When I do that, this is what I end up with. Like I said, cosine A is just like having x. So this is like having negative 128 times x. In order to isolate the variable, I need to go ahead and divide. When I do that, this is what I'm having. A lot of you asked questions on Friday about exactly what's happening at this step, so I chose to write it out in a different manner. Just like when we were trying to find cosine of theta or sine of theta, this is what would happen. We would need to divide, and then we would need to do the inverse cosine in order to find out what the measure of angle A is. In this problem, it's 77 degrees. So this is what you would use to figure out the vertex angle. Sometimes they do ask for the base angles, but since we know that these two angles are congruent, it's not too hard to find. This is the easiest example, and my second example is very similar to this example, although it's presented in a different way. Example 2. Find the acute angle formed by the diagonals of a rectangle with sides of 6 feet and 8 feet. Underneath this green box is my picture of my rectangle. I want to take a look and put the numbers about where they would belong. The longer side should be 8 feet. The shorter side should be 6 feet. Now I want to be able to know the measure of the diagonal as well, and since I know it's a rectangle and I know it makes two right triangles, I can see that there's actually a triple here, which is 10 feet. Now you notice I have this 5 feet here. It's going to come back up in a minute. We're finding the acute angle formed by the diagonals, so we do need to have a second diagonal in this problem, and I do have one behind here. Sorry about that. And it will go right here. One thing we know from when we talked about quadrilateral properties is that the diagonals do bisect each other. And they are also congruent, therefore every single cross section of the diagonal is 5 feet. So this is what we have. Now we want to find the acute angle. Knowing what we know about angles and the sides opposite those angles, my prediction is that the acute angle is here because this angle is across from the shortest side. I'll give you some background just in case something happens and you don't find the acute angle. We'll discuss what we can do. The first thing we want to do is use law of cosines again. We are trying to find this angle right here between the 5 and the 5 and across from the 6. Like the vertex angle question, you notice you're using most of the same numbers on this side, which leads to this step here. What I did is I simplified each set of squares. I multiplied 2 times 5 times 5. I isolated my cosine A. In my last step, what I'm going to do is divide by -50, inverse cosine that, and I find the angle is 74 degrees. Now with this problem, one thing you want to keep in mind is, let's say that you end up getting something like 106. It has to be acute. What we know about the two angles formed by the diagonals is they are supplementary. They make up a straight line. They're a linear pair. So whatever angle you do get, in case it's obtuse, subtract it from 180 and you'll be in good shape. You will have an example like this to do for your turn now, so you'll get another opportunity to try it. Unlike examples 1 and 2, example 3 requires a lot of extra steps. This particular question has appeared on chapter tests and finals, and while there are many ways to solve it, I'm going to teach you one specific strategy so that all of our answers tend to be pretty similar. Now our question asks us to find the area. So that's what we need to be able to find. In order to find the area, I need to determine the height. And at this point, I don't have anything I can use to find the height. The triangle is not isosceles, it's not equilateral, and it's not a right triangle. So if I can find an angle, I'll show you in just a minute how we can figure it out. Now notice I set up my numbers in a kind of different pattern. We're using an arbitrary triangle, which means I'm just using a triangle for the sake of illustrating the problem. It is not drawn to scale by any means. If I want to find the angle opposite of 11, I want to use the law of cosines. Now I'm going to go through this step relatively quickly because we've now just done 2 more examples using the law of cosines. So I plug in my numbers, and because it's not isosceles like our other examples, we're not going to need to worry too much about everything being the same. So I'm just going to go through and just show you the steps that I did here, just to recap. I simplified my squares, and I did my product over here in this step. I subtracted 130 to begin to isolate cosine of A, and then when I got down to this step down here, I needed to isolate further by dividing. I need to do the inverse cosine, and I come up that the angle down here is 86 degrees, and that seems fairly reasonable considering that all 3 sides are rather close together, and that 11 would be the biggest angle, so it's right under 80 degrees, which makes sense. Now you may be wondering, why did I find an angle when I need to know the height? This is why. In the triangle, if I know 86 degrees is an angle, I know that the height of a triangle is perpendicular to the base, that I can use what we did earlier this chapter to find the height. So I know an angle in a right triangle. I know that the height is the side opposite that angle, and I know that the 9 is the hypotenuse of just this half. So opposite over hypotenuse means I use sine. Now notice, this is not law of sines or law of cosines. This is just what we already know. And just to reiterate, we can't split the base and do what we did because this triangle is not isosceles. This is our only way to find the height. I did the calculation and I came up with this. I typed exactly on my screen what was in my calculator because we really don't want to round. We just want to leave this number in the calculator, and I can show you some things with that. Now that we have the height, we know our base is 7. We already have that determined. Area equals base times height divided by 2. So I did 7 times my long number for height, divided it by 2, and ended up with this. Now, one thing you might be asking yourself is, why did I arrange the numbers like I did around the triangle, and could you get the same answer if you rearranged them? The answer is pretty much yes, you can get the same answer. It really doesn't matter the order that you put your numbers in. For instance, I tested if I moved around 9 and 7, and I ended up with 31 and 43 units squared. Because this is a constructed response question, there will be some room for error. We call that tolerance. So don't get yourself too alarmed. There are multiple ways to solve it, and based on how we round things and how different numbers are found, it could change things up a little bit. For your turn now, I just picked 2 of the questions for you to try. There's no reason to look at the first question again, because honestly, if you can do the second question, you can do the first question. And I do have a typo here. This one is actually like example 2. Let me fix that for you. So take your time, take a look at these questions. Remember, in class we are going to actually practice these a lot, and I'll probably do a little bit more direct teaching for small groups who have some trouble.